So, we are required to find out limit of mod x sin x, the function is mod x sin x as x goes to 0. So, as such we cannot apply because whatever we had we have only for polynomials x, constants, polynomials and so on, but here mod x and sin x. Okay. So, what we do? We try to estimate this from both the sides, say having some inequality, think of some inequality. So, what it says sin x can be maximum 1 and minimum minus 1. So, wherever x may be, minus 1 is less than or equal to sin x less than or equal to 1. So, if I multiply mod x and x goes to 0, so x is not 0. Anyway, so it can be multiplied still even if it is 0. So, multiplying mod x we get minus mod x less than or equal to mod x sin x less than or equal to mod x. Now, look at the both the sides, this function and this function. As x goes to 0, both of them go to 0. That is clear. Limit of, it is the limit of minus mod x, that is also 0. So, use sandwich theorem which gives you that limit of this sandwiched function should also be equal to same as those two limits, that is limit of x goes to 0 mod x sin x equal to 0. Okay. So, now we ask if it is this way, if you think of sin x, you may take minus 1 and 1, but that will not yield any limit, because minus 1 and 1 limits are really minus 1 and 1, they do not give. So, how to go about limit x goes to 0 sin x? Okay. We use again the same inequality whatever we had done earlier, but in a different way now. We have the inequality that sin x is always less than or equal to mod x. So, it is not minus 1 to 1, but it is something else, that is sin x is less than or equal to mod x. Similarly, minus mod x is less than or equal to also sin x, okay, for any x around 0. Then you use sandwich theorem, because these two limits are 0. So, that gives you limit sin x is also equal to 0. But these inequalities are really helpful, some of them we will discuss, we have really mentioned them earlier, sin x less than or equal to mod x and similar things. Similarly, for cos x, but cos x we do not have cos x mod is less than or equal to mod x or something, but something else is there. What is it? If you take 1 minus cos x, that is less than or equal to mod x. This is the inequality we have discussed earlier, and we know that cos x is always less than or equal to 1. So, we can say 0 less than or equal to 1 minus cos x less than or equal to mod x. Once you see this estimate, then you just see that as x goes to 0, this mod x goes to 0 and this is already 0. So, by sandwich theorem again limit x goes to 0, 1 minus cos x equal to 0. Then by algebra of limits, limit of cos x should be equal to 1, because the right side limit, left side is limit of 1 minus limit of cos x, and limit of 1 is 1 and total is 0. So, limit of cos x must be equal to 1, that is what it says. So, this kind of estimates you keep in mind, they will come off handy. Now, let us find out another which asks for finding the limit as x goes to 0 of this function, which is a ratio of two functions. On the top we have x square plus 100 square root minus 10 divided by x square. So, when x is not equal to 0, these are well defined, but when x goes to 0, we cannot just apply the limit earlier, limit of f x divided by limit of g x, because this denominator limit is equal to 0. So, what do we do? We try to rewrite just like your x square minus 9 divided by x plus 3, same way we have to rewrite it. So, we multiply square root of x square plus 100 plus 10. So, that denominator was 0 earlier, now it will not be 0, that is our purpose, to bring it to some form where denominator may not be 0, but it can be 0 here. Let us see how to proceed. This is some guesswork we try, because square root also we want to take away. Okay, once you multiply this square root of x square plus 100 plus 10, then on the top it becomes square root of x square plus 100 whole square minus 10 square. So, that is simplified, this becomes x square plus 100 minus 100. So, that gives you x square. Now, this x square and this x square gets cancelled. That is the main idea of making the denominator non-zero. So, once this x square gets cancelled, all that remains is square root of x square plus 100 plus 10 and the top there is 1, right, because this is numerator is x square really. Now, you can take the limit and the denominator is non-zero, limit of square root of this as x to the power r we apply now. So, it is limit of x square plus 100 to the power half. Limit of x square plus 100 will be equal to square root of 100. So, that is 10. So, 1 divided by 10 plus 10 which is 1 divided by 20. Okay. So, now it is given that limit of mod f x equal to 0. What can you say about the limit of f x? Does it really exist or it does not? Okay, suppose you take limit of mod x. What will happen to limit of mod x as x goes to 0? We know that this is equal to 0 and we know that limit of x also equal to 0. But the question is, does it imply that limit of x equal to 0? Well, that is also correct. So, it implies, but then how to bring x from mod x? The well known inequality we can see that mod x is less than or equal to x is less than or equal to mod x. So, if you take minus of mod x, it is less than or equal to x and that is always bounded by mod x. Now, you can use sandwich. So, similar way we will be doing here, limit of mod f x is given. So, we can have an estimate for f x which looks like minus of mod f x less than or equal to f of x less than or equal to mod f x. Now, use sandwich theorem. The left side gives 0, right side also goes to 0 as x goes to 0. Therefore, the sandwiched function. So, limit x goes to c f x which c is here really 0, limit x goes to 0 mod of f x must be 0. Okay. That is what it says. Then let us apply all these techniques whatever we have learnt on some more problems. So, it is not given that the limits exist. If possible, find the following limits. If not, then we have to say that the limit does not exist. Okay, so, for the first one, it says x square minus 2x minus 3 as the numerator and x square minus 4x plus 3 in the denominator. So, first thing we have to check is when x goes to 3, what happens to the denominator? That will become really 9 minus 12 plus 3 which is 0. So, that means x minus 3 is a factor. So, first question we should ask, is x minus 3 a factor of the numerator? Then we can cancel it. So, let us see what happens. So, it is not defined at x equal to 3, but it is okay because we need in the limit x need not be equal to 3. So, now numerator can be factored as x minus 3 into x plus 1. Just check it, it is x square minus 3x plus x minus 3. So, that is x square minus 2x minus 3 and denominator has a factor x minus 3, it is x minus 3 into x minus 1. So, after cancelling we can cancel because x is not equal to 3 in the limiting process. So, it is limit x goes to 3 x plus 1 by x minus 1. Now, x goes to 3. So, on the top since limit of x goes to 3 is 3. So, it is 3 plus 1 divided by 3 minus 1 which is equal to 2. Okay. So, let us see the second one b, which says we have to find limit of 1 minus square root of 3x plus 1 by x. Again x goes to 0. So, we have to take away this x somehow. So, what do we do? Usually this is the case in such problems that we have to rationalize the square root. So, we multiply 1 plus square root of 3x plus 1. It was 1 minus on the top, now 1 plus we multiply. So, the numerator becomes 1 square minus this which is 1 minus square root of 3x plus 1 square. So, it is really minus 3x and minus 3x and this x they get cancelled. So, you get minus 3 on the numerator and the denominator is 1 plus square root of 3x plus 1. Now, you can take the limit under this square root, limit of 3x as x goes to 0 becomes 0 So, this is square root of 1, it is really non-negative square root, which is 1 again. So, 1 plus 1 becomes 2, on the top anyway it is minus 3. So, limit is minus 3 by 2. So, let us see the third one, C. So, C is limit of 5x cubed plus 8x square divided by 3x fourth minus 16x square as x goes to 0. So, again the denominator goes to 0 as x goes to 0. So, the any factoring is possible, that is our question. So, we see that it is x square we can take out from here, it is x square times 3x square minus 16, and the top also is x square times 5x plus 8. So, we cancel this x square and we get 5x plus 8 divided by 3x square minus 16, and then we can find the limit of the numerator and denominator separately and divide them. So, that gives rise to 8, 5x plus 8. So, x goes to 0, it is 8, and this is minus 16. So, it is minus half. Okay. I think till now it is all right. So, let us go to another exercise. It is given that f of x satisfies square root of 5 minus 2x square less than f x less than square root of 5 plus 2x square. So, very tight, square root of 5 minus 2x square plus 2x square, where or for x is in the open interval minus 1 to 1. There only we have f x defined now. Let us assume that. Now, g x is another function which satisfies 2 minus x square less than g x less than 2 cos x. But this is in the interval minus half to 1 by 3. So, one is minus 1 to 1, another is minus half, here is 0 to say 1 by 3. So, both are defined in minus half to 1 by 3 anyway, and they will satisfy the same inequalities. We want to find limit x goes to 0 f x g x. Since x goes to 0, so we can even consider a smaller interval where it is defined. So, both are defined in minus half to 1 by 3. So, f x times g x is also defined there. They might be defined, but at least we have these inequalities satisfied there. So, exploiting these two inequalities, we have to do something which f x times g x, which will be valid inside in a neighborhood around 0. So, that should not exceed, that delta should not exceed 1 by 3 anyway, that neighborhood should be inside this, and we can always limit that way, because limit needs only nearness, we can make it smaller even. Okay. So, assume that both the inequalities hold for x near 0 and try to find out f x g x, that is our question. Okay. So, what do we see? Limit of, since both the conditions hold, limit of f x we can see from the sandwich theorem as x goes to 0, it is square root of 5 square root of 5, right. So, limit of f x is square root of 5. Similarly, limit of g x is also as x goes to 0, it is 2 on the left side, 2 on the right side, cos x goes to 1. So, this becomes 2. So, limit of f x g x must be equal to 2 into square root of 5. If you attempt at a time, there might be some difficulties, but it is okay. This will be easier, right. You find here it is easier to find limit f x and limit g x separately. Okay. So, now this third problem, which says suppose x fourth is less than or equal to f x is less than to x square, again in the interval minus 1 to 1, but now it is closed interval minus 1 to 1. So, inequality is satisfied in this interval, and similarly x square is less than or equal to f x less than or equal to x 4, it is the other way around now, for x less than minus 1 and x square is less than or equal to f x less than or equal to x fourth for x greater than 1. So, that means at minus 1, at 1 this inequality, within that also this inequality, and elsewhere we have this inequality. Then we have to find limit of f x as x goes to c for all possible points c. Okay. Suppose it is at 0, suppose c equal to 0, then only one inequality is satisfied. We are looking at this only. So, this will not be relevant for x c is near 0. So, once this happens, we see that x fourth go to 0, x square goes to 0. So, f x will go to 0. Limit of f x must be 0 by Sandwich theorem when x goes to 0. Similarly, suppose it is x is less than minus 1. So, let us say c is something which is less than minus 1. Then this inequality will not be applicable, this is only applicable. Then you can think of what is going on here, right. Similarly, if x is bigger than 1, only this one is applicable, second one, first one inequality will not be satisfied. And x at minus 1 and 1, this is really satisfied, this inequality, but in the limiting process, we are thinking of the neighborhood. They can be near, not equal to. So, the other inequality also becomes relevant. So, as per our procedure, if we use only Sandwich theorem, at which points you can really find the limit by using Sandwich theorem. And this information can only be used that way as of now. So, let us say using Sandwich theorem, what limit we can get, for which c we can get the limit. So, if we want to use Sandwich theorem, then in either case it is x fourth and this is x square, this is x square and x fourth, their limits should be same, then only you can use the Sandwich theorem. And when limits of x square and limit of x square are same, so that means it is c square must be equal to c fourth, their limit x goes to c of x square is c square and x goes to c of x fourth is c fourth. So, it gets c square must be equal to c fourth. That would give c to be one of these points minus 1, 0 or 1. So, only at those points, of course, by inspection we are coming to that. Now, this really makes it solid that if you use only Sandwich theorem, no other tools are there to be used, then we can possibly find out its limit at minus 1 or 0 or 1. So, at these points what will be the limit? Limit x goes to minus 1 f of x will be equal to 1. Why is it so? Limit f of x, x goes to minus 1. So, where minus 1 will be applicable? If it is less than minus 1, it is this inequality applicable. If it is greater than minus 1, then this inequality is applicable. So, both the things are applicable. But when x goes to minus 1, limit of x fourth and limit of x square both are 1. So, by Sandwich theorem, limit of f x goes to minus 1 equal to 1. Similarly, at 0, both the things, not both the things, only this one will be applicable and that gives us 0, both the sides, therefore, limit equal to 0. And when c equal to 1, so limit of x goes to 1 of f x, then this is applicable, x is greater than 1, this is also applicable, x is smaller than 1, but in both the cases, the both side functions go to 1. So, limit must be equal to 1. So, this is how we are proceeding for the third problem. Okay. So, let us take the fourth one. Suppose limit of x goes to 4, f of x minus 5 divided by x minus 2 equal to 1. So, you see here the denominator limit equal to 2 really. So, it is not 0, then we are safer. We do not have to use any specific things here. It should be quicker, just algebraically we should get. Find out limit of f x, x goes to 4. So, we just rewrite f x using that, f of x equal to 5 plus f x minus 5 by x minus 2 into x minus 2. You can verify it easily. So, now f x minus 5 limit is equal to 1, that is given. So, this limit equal to 1 and limit of x minus 2 x goes to 4, that is 2. So, it is 5 plus 1 into 2 which is 7. Now, similarly, one more is there, say f x minus 5 by x minus 2, limit x goes to 2 now equal to 1. So, that means x minus 2 limit on the denominator, that becomes 0 now, and if this limit exists, x minus 2 is 0, then as we have learned earlier that the limit of the numerator must also be 0. Therefore, limit of f x, x goes to 2 must be equal to 5. But we can also use the earlier thing, rewriting, and see what happens. We can write f of x equal to 5 plus f x minus 5 by x minus 2 into x minus 2 as earlier. Then we take limit f x goes to 2, that gives you 5 plus this limit times limit this x minus 2. So, that gives 5 plus 1 into 0 equal to 5. Okay, that is easy.